Okay, so let's get back into Glencoe Algebra 2, Section 1-3, Solving Equations. We've already discussed examples 1 and 2, which dealt primarily with the order of operations. Please excuse my dear Aunt Sally, PEMDAS. Example 3, we're going to skip as of this point in time. It's not something that we need to cover. So I want to pick up and get into examples 4 to 7. So before we move into the examples, I do want to talk about some properties of equality, specifically the addition and subtraction properties of equality and the multiplication and division properties of equality. Now, equality. It's important that we understand in math what equality actually means. What does an equal sign tell you? Well, the equal sign tells you that whatever's on the left-hand side of the equal sign and what's on the right-hand side of the equal sign are the same. So in order to actually do math and work with the numbers and the variables that we may see in equations, we have to make sure that what we're doing ensures that the left side of the equal sign and the right side of the equal sign remain the same. So if we look here at the addition and subtraction properties of equality, for any real numbers a, b, and c, if a equals b, then a plus c equals b plus c. So you can see that we're adding c on both sides. And that's okay, because as long as we're adding the same value on both sides, we're maintaining that the left and right sides of the equal sign stay the same. And the same property exists for subtraction. You can see a minus c and b minus c are still equal. So in the example that they said here, x minus 6 equals 14, then x minus 6 plus 6 is equal to 14 plus 6. Now, it's kind of coincidence, and there is a point to it, which we're going to talk about, but the fact that we are subtracting 6 and adding 6, that addition of 6 on both sides doesn't have to be a 6. We can choose any number. We could have chosen x minus 6 plus 7 is equal to 14 plus 7. That's still a true statement. So I don't want anybody to get hung up on the fact that they use the same value, minus 6 and plus 6, in the equation. It is something that's important, and it's important because subtracting 6 and adding 6 are opposites. And so minus 6 plus 6 actually becomes 0, and that's going to leave x all by itself on the left side of this equation. And that's something really important that we're going to talk about today in terms of solving equations. So again, just like addition and subtraction, we have these properties of equality. These are things that we can do with addition and subtraction to both sides of the equation and maintain that the left and right sides stay equal to each other. Well, the same things exist for multiplication and division. So you can see in the example here with using a, b, and c is not allowed to be 0. If a equals b, then a times c is equal to b times c. So multiplying by the same number on both sides of an equation maintains that equality. And likewise, dividing by the same number on both sides of the equation maintains that equality also. And so these, again, are going to be important in helping us do things like isolate a variable in order to solve for it. So in these examples down here, you can see we have m divided by 8 equals negative 7. We are multiplying by 8 on both sides, here and here. And what happens then, we know that when we have an 8 on top and an 8 on the bottom, they're going to cancel out, and again, we're going to be able to isolate that m. And that's why these properties are important, because we're going to find that we're going to need to do the inverse operations as we try to solve equations. Okay, so let's move forward, and I want to kind of look at how we use these to isolate a variable. Again, here I've pointed out that adding 6 and then subtracting 6 result in a value of 0, thus leaving x by itself. And multiplying by 8 and dividing by 8, again, inverse operations. Addition and subtraction are inverse. Multiplication and division are inverses. Leaves us with the variable alone and allows us to come up with a value to solve for a particular variable. So let's move over and take a look at example 4. So, example 4 here, called solve one-step equations. And you can see the instructions say solve each equation, check your solution. So, when we say solve each equation, what we're looking for is we're looking for a value of n that we could put into this equation right here. That would mean that this value n minus 3.24 is equal to 42.1. So we're going to look at this and we're going to say, okay, just like we saw in the equality properties that we just looked at for addition, subtraction, multiplication, and division, we have ways where we can isolate a variable. So sometimes I like to talk about this as what in the problem is being done to the variable. Well, in this case, the variable n is having 3.24 subtracted away from it. So we kind of want to undo that subtraction by doing that inverse operation. So the first thing that we're going to do here is we can add 3.24 on this side. Now, by adding 3.24 on this side, we already saw that subtracting 3.24 and adding 3.24 is going to make this add up to 0. And that's going to leave our n all by itself. We essentially now have n plus 0, or just n by itself on the left side of the equation. And that's exactly what we're looking for. That's exactly what we want to do. But since we have to maintain equality between the left and right hand sides, since we added 3.24 to the left side, we also have to add 3.24 to the right. So 42.1 plus 3.24 is equal to 45.34. So we find out here that n is equal to 45.34. Now, all we did is we added 3.24 on both sides of the equation, maintaining that equality and excuse me, being able to get rid of the minus 3.24 that the original equation started with. I do also want to point out here that the instructions say check your solution. How do you check your solution? We're going to check our solution by actually substituting the value that we found as our answer for n into the original equation for n. So I'm going to rewrite this now as 45.34 minus 3.24. See, the n value went right here. We're going to subtract 3.24, and we're going to then see, does this actually equal 42.1? And if I punch this in my calculator, 45.34 minus 3.24, I do find out that it is actually equal to 42.1, and therefore I can be confident that I have found the correct answer for n for this particular equation. Now, these are called one-step equations because it only took one step to solve it. We are going to look at multi-step equations, but for example 4, for right now, we're going to practice just doing single-step equations. We did one thing. We added 3.24 to both sides. So one single step, and that allowed us to get n all by itself and allowed us to find the value, 45.34, for n. Okay, so to solve example A, we use the addition and subtraction property of equality. In example B, we're going to practice using the multiplication and division property of equality. So what we have here is we have negative 5/8 x equals 20. So negative 5/8 times x equals 20. So we need to do the inverse operation of multiplying by negative 5/8. So again, like we did above, let's talk about what we're doing to x. Well, we can see right here that we are multiplying x by the value negative 5/8. So the inverse operation of multiplication is division. So we're going to divide in this case, and we're going to divide both sides by the value negative 5/8. So I can come right over here and I can set this up like so. Divide by negative 5/8. Now, one thing that's important to note is dividing by negative 5/8, we don't generally love fractions. Most people don't love fractions. what we could do is we do know that dividing by a fraction is the same thing as flipping the fraction over and instead multiplying. So we could do that on both sides also. In fact, let me set that up over here. We have negative 5/8 times x equals 20. So what I can do is I can then multiply both sides by negative 8/5. And multiplying by negative 8/5 on both sides is the same thing as dividing by negative 5/8. So one good thing that we can take out of this is when we have a fraction and we're multiplying by that fraction, we can undo that multiplication by flipping the fraction over and multiplying by it. Now, in order to maintain our equality, since we do have an equal sign here in the middle, we need to also multiply by negative 8/5 on the other side of the equation. So a negative times a negative becomes a positive. 8 on top, 8 on bottom, cancel out. 5 on bottom, 5 on top, cancel out. This inverse operation right here essentially becomes a 1. Okay? 5/8 times 8/5, negative, negative. We end up with 1x, or just x, and that's going to be equal to 20 times negative 8/5. Now, 20 times negative 8/5, we can pull out our calculators here to make that easier. That's 20 times negative 8 divided by 5, and we find out that 20 times negative 8/5 is equal to negative 32. And in this case, since we have 1x, which is just x is equal to negative 32. And again, we could go back and check our solution, and we can plug into the equation and multiply negative 32 by negative 5/8 and find out that it is in fact equal to 20. This is a correct answer. So in example 4 here, for A and for B, we've seen that we can isolate a variable. Isolate means get it by itself, by doing the inverse operation of what's already being done to the variable in the question. Okay, and by doing that and making sure to do that on both sides, we maintain our equality and we can solve for the variable that is missing. So let's move to the next screen. We have two guided practice problems here. 4A asks you to practice using the addition and subtraction equality property, and 4B asks you to practice the multiplication and division equality property. So now's a good time to pause, try these out, and the answers will be presented at the end of this lesson. Okay, great. Now if you finish the guided practice, we can move on. So I cut and pasted this from the book because I feel like this is a huge oversimplification. We just solved one-step equations. We only needed to do one thing. We added something on both sides, or we multiplied by something on both sides, and that was the only thing that we needed to do. So as we work towards and move forward and get closer to solving multi-step equations, where we're going to have to do 1, 2, 3, 4, any number of things in order to get that variable by itself, the book throws in this statement: to solve an equation with more than one operation, undo operations by working backward. Well, what exactly does that mean? So in order to understand that, I first said, okay, let's go back and let's take a look at how we do the math. Instead of undoing operations, let's make sure we're totally good on doing operations. We learned in the first lesson of 1-3 that please excuse my dear Aunt Sally is the order of operations, and that means that we do things inside parentheses first, then we worry about exponents, multiply, divide, add, subtract, until we get to the final answer. So here's an example. 1/3 times the quantity 12 plus 12 equals something, and I'm going to put an x there. It's like a variable. Essentially what we're doing is we're trying to find out what x is. What is the final answer? And so if we actually go through here, we start with p parentheses. There is math that we can do inside the parentheses. 12 plus 12 is 24. So we can simplify this to 1/3 times 24 equals x. And now we have one step left, multiplication. 1/3 times 24, or 24 divided by 3, is 8. And we find out that 8 is equal to x. So we were able to follow the order of operations, starting at P and moving in this direction towards subtraction. Please excuse my dear Aunt Sally. So what I want to do is I want to take a look at the same equation and see if we can solve for a particular value. And what I mean by that is I'm going to change the location of the x. So I'm going to rewrite this as 1/3 times x plus 12, and I want to see what value I could put in for x that will give me the result 8. Now, we already know that in order to get x equals 8, meaning x being the final answer over here, we would want the value 12 here. So we know what the answer should come out to be before we actually try to do this. Okay, so let's try to solve this. Let's read this again. This does have multiple steps. We cannot just do one operation, being some addition or multiplication, to solve this. And so it says to solve an equation with more than one operation, undo operations by working backward. Backward? What does that mean? Well, backward in this case means the opposite of PEMDAS, the opposite of please excuse my dear Aunt Sally. So sometimes it helps, and I like to write this out as SAD-MEP. Instead of PEMDAS, we have SAD-MEP. All right, Sally, Aunt, dear, my, excuse, please. We're actually going to do things, or I'm sorry, undo things in the reverse order. So instead of starting at the parentheses, we're going to do the parentheses last. And instead of ending with subtraction, we're going to do subtraction first if there is any. And so in this particular problem, we're actually going to say, hey, I have this big set of parentheses here. I can't touch any of that. So because we're doing inside the parentheses last, we're going to start with any subtraction. Well, I don't see any subtraction in there, and I don't see any addition. I do see some multiplication, so we can kind of jump right up here to the m, and we can say, hey, 1/3 times the parentheses section, x plus 12. And so I want to undo that multiplication first. And what we just talked about on the last screen, or 2 screens ago, is that when you have multiplication by a fraction, we can undo that multiplication by flipping our fraction over and multiplying. So 1/3, we're going to multiply by 3/1. And whatever we do on the left, we also have to do on the right. So we're going to multiply by 3/1 here. Well, of course, 3/1 is just 3, and 1/3 times 3, or we have 3's that cancel out and 1's that cancel out. So we end up with a 1 here, which is nice. And that leaves us with x plus 12. Now, the parentheses, we don't need them anymore because there's nothing else going on that side. And that's going to be equal to 8 times 3 is 24. So x plus 12 equals 24. This now should be a one-step equation to solve. Just like before, we can now use our inequality properties. And so what we can do is we can say, hey, x plus 12, I want to get that x by itself. I'm adding 12 to it. This is what I'm doing to the x. So to undo adding 12, I'm going to subtract 12. And plus 12 minus 12 is 0. And so we are left with the x all by itself. So we're getting very close here. Our x is by itself. And since we subtracted 12 on the left-hand side, we also have to subtract 12 on the right-hand side. And 24 minus 12 is equal to 12, which we already knew the answer should be. So we're going to undo operations by working backward. And what does backward mean? Backward means doing please excuse my dear Aunt Sally backwards. Sally, Aunt, dear, my excuse, please. One other way to do this, and I do want to redo this problem on the next screen, and I want to redo it a slightly different way, and a way that I think is going to help simplify things and make some of these problems easier for you moving forward. But the general idea is that we're going to undo the operations by doing them in the opposite order that we would do the math, the opposite of please excuse my dear Aunt Sally. So let's move to the next screen. Okay, so here I'm going to rewrite that problem. 1/3 times x plus 12 equals 8. And so one of the things that I think can get confusing when you're solving these equations is when there's parentheses involved. And so I want to kind of suggest a method to help get rid of the parentheses, because getting rid of the parentheses is going to kind of make things be a little bit more straightforward. So I kind of want to write a little set of steps over here for you to kind of follow in general. So step one, I'm going to say, is do math. So in these problems, you want to kind of do as much math as you can and really simplify what's on the screen. So you're going to do math, and that means you're going to do things like distribute if you can. If you can distribute a value into parentheses, that will help you get rid of them. You're going to try to follow, please excuse my dear Aunt Sally, as far as you possibly can. And then that way you don't have extra operations that you need to undo. If you can simplify things and make them become a single value, then you can save yourself a little bit of trouble when you get to the undo kind of backwards stage. So in this case, when I say step one, do the math, I'm kind of focusing on this distribute part here. So I'm going to take my 1/3 and I'm going to distribute my 1/3 into my parentheses. So 1/3 times x is 1/3 x plus 1/3 times 12 is 4, and that's still going to be equal to 8. That doesn't change anything. So now, once we have done the math, we do see that this does look a little simpler, and again, we've taken the parentheses away, and so now we want to kind of start to follow SADMEP, that backwards, please excuse my dear Aunt Sally. I do want to point out that a step 2 here would be combine like terms, if that's possible. And we are going to see some combine like terms as we do some of the examples that we see here in section 1-3. So I do want to point that out. And then we're going to jump right now all the way to step 3, which is undo the math. So any math that you couldn't do because there were variables involved. What I mean by that is we can't add 4 to 1/3 x because we don't know what that x is. So we're not allowed to do that step. So we're going to undo it. So we're going to undo any math that we were not able to do. And basically there I'm saying we need to follow that backwards SADMEP routine. So starting at subtraction, is there subtraction to be done? In this case there is, and actually most times we're going to kind of pair these up, subtraction and addition. And remember, they're inverse operations, and we're going to be able to kind of pair up division and multiplication. So we're going to start with the subtraction addition. So I see a +4 here in this equation, and I know to make that +4 go away, which is going to get us closer to the x being alone, that I want to subtract 4. So I'm going to subtract 4. Adding 4 and then subtracting 4 is basically 0. So this is going to go away. And if I subtract 4 on the left-hand side of my equal sign, I also have to subtract 4 on the right-hand side. And now I can go through and actually perform these operations. +4 minus 4 is going to result in 0, and that's going to leave me with my 1/3 x all by itself on the left-hand side. And that's got to be set equal to 8 minus 4 is 4. So you can see that I am getting closer and closer to being done this problem because x is almost alone on the left-hand side. So now I don't see any more subtraction or addition, and so now I can move to that division multiplication part of SADMEP. And so I see that I'm multiplying x by 1/3, and what we've talked about a couple times already now is that I can multiply by the opposite. I can multiply by the inverse. I can flip the fraction over and multiply, and 3/1 times 1/3 is just a 1. And that leaves me with 1x, or just x. And if I multiplied by 3/1 on one side, I have to multiply by 3/1 on the other. So 4 times 3 is 12. 12/1 is 12. So I'm going to get x equals 12. I get the same answer. It's a correct answer. And it kind of, in this process, gave us a little bit different way to handle this that I think is going to make some of this stuff coming up a little bit easier for you. Okay, so example 5, solve a multi-step equation. So we want to find out what x is here. What x can we put into this equation in both places, because x does show up twice, that will make this a true statement. That will make the left-hand side be the same as the right-hand side. So let's follow our steps. Let me remind us what our steps are that we wrote down over here. We said 1, do the math. And that included, please excuse my dear Aunt Sally, doing any multiplying or any math that we can do before we run into variable issues. Distribution, and the idea in doing this step is to help us get rid of some of the parentheses, which you can see we have in our problem that may make things a little bit hairier. Step 2, combine like terms. So we may need to combine like terms here in order to help us find out what x is. And since x does show up twice, we may need to do this combine like terms step in order to put the x together to find out one specific value for x. And then finally, step 3 is undo the math. So that's a situation where we have our variable and some math is being done to it, and we need to undo that math to get our variable alone on one side of the equal sign. So let's go ahead and start to apply these 3 steps to this problem. Okay, step 1, do the math. So I don't see any math in here that I can do. If we try to follow please excuse my dear Aunt Sally, I see that inside my parentheses I have variables, so I can't do any of that adding or subtracting that's in there. I don't see any multiplication or division or additional addition and subtraction that I can perform right now. So maybe we can distribute though. Maybe that'll help, and that'll help us get rid of some of those parentheses, possibly all of those parentheses. So let's start right here. We're going to distribute the 5 in here, like that. 5 times x is going to give us 5x. 5 times 3 is going to give us 15. So we have 5 times x, and 5 times plus 3 gives us 15. Then we have plus, and I'm going to distribute my 2 in here, like so. 2 times 1, so positive 2, and 2 times negative x is going to be minus 2x, and that whole equation is still equal to 14. So now I have the exact same equation. All I've done is distribute on my left-hand side, but it has a new look. And I'm starting now to actually see some math that I can do. There are no parentheses left. There are no exponents. There's no more multiplication to do. 5 times x and negative 2 times x I can't do because I don't know what x is. There's no division. I do see some addition here. 15 plus 2. I can do that. I can't do 5x plus 2 because, again, I don't know what the x is. But 15 plus 2 is addition that I can do. And if I rearrange the equation, I do actually even see some like terms here. A 5x and a minus 2x. So if we combine like terms, which is step 2, we can put this into a little bit nicer form and make this a little bit simpler. So 5x minus 2x, let's do that first, is going to be 3x. So 3x plus 15 plus 2 is 17, and that's everything on the left is equal to 14. So now my equation has a much different look to it. I assure you that it is still the same equation. We haven't done anything wrong. All we've done is change the way it looks. So now I can go ahead and do step 3 where I'm going to try to undo the math. So my x in my equation is located right here. I want to try to get it by itself, and you can see that what we're doing to it is we are multiplying it by 3 times x, and we are adding 17 to it. And so when we're undoing the math, according to SADMEP, which is the backwards version of please excuse my dear Aunt Sally, we want to start by undoing that addition and subtraction first. So the plus 17 is where we're going to focus to start, and we know that in order to undo adding 17, we learned from our addition and subtraction property of equality that we would subtract 17. So we're going to subtract 17 on the left-hand side, and since we're subtracting 17 on the left-hand side, we also need to subtract 17 on the right-hand side. So positive 17 minus 17 leaves us with 0, and now we have 3x equals 14 minus 17 is negative 3. So 3x equals negative 3. And we're going to need to determine what is the value of x here that when we multiply it by 3 will give us the value negative 3. So there's no more addition and subtraction to do as we move in this direction, sad map. But we do see multiplication. And so in this case I'm multiplying by 3. And we know that the inverse operation of multiplication is division. And so what I'm going to do is I'm going to divide by 3 on both sides. Dividing by 3 undoes multiplication by 3. And so if I'm going to divide by 3 on the left, then I also need to divide by 3 on the right. And 3 divided by 3 is 1. Leaves me with 1x, or just x. And negative 3 divided by 3 is negative 1. And so I can find out here that in example 5, the x value that I could plug back into my equation and for both x's and get the right value, 14, on the right-hand side, is negative 1. So you can see we followed our 3 steps here. We did math, we distributed, we combined like terms, and then we undid the math by using SADMEP. Sally, Aunt, Dear, My, Excuse, Please. Let's move over to the next screen. Here's 2 guided practice problems for you to try out. Pause the video now. Answers to these will show up at the end of this video. Okay, good work. Quick recap here. I just want to remind everybody, most of the time we're going to see, please excuse my dear Aunt Sally. It's not common for you to see SADMEP anywhere, but so what I want to do is I want to kind of write this down and make sure that we see this and that we have this as a little bit of a visual aid to use in doing this. So please excuse my dear Aunt Sally, working in this direction is the direction that you do math. Okay, you start with parentheses and you move to exponents, multiply, divide, add, and subtract. And moving in this direction is the direction that you go to undo the math. We always need to undo subtraction and addition first, then undo multiplication and division, then look for exponents, and then work inside the parentheses. And as always with the parentheses, we are working in that same order inside the parentheses. So let's keep that in mind, that little visual. That might be something good to write down now. But let's move over here to example 6. Example 6 comes from geometry, but it's really just algebra, and it's working with symbols. That's why we're doing this, to get familiar with working with no numbers. So that do the math portion is kind of going to be non-existent. It's going to be really hard to do any math here because we don't have any numbers. These are all just variables. And in this case, we want to take the formula for the area of a trapezoid, which is A equals 1/2 the height times base 1 plus base 2, where h is the height, b1 and b2 are the bases, and we want to solve this for b2. So essentially, b2 is our x. We want to make this equation say b2 equals. And you can see that b2 is not alone on one side of the equal sign. So we're going to need to undo all of the math that we're doing to b2 in order to get it alone. Okay, so I think it's important to be able to identify what's being done to b2. So b2 is having b1 added to it, but that's inside the parentheses. So we're going to have to save that parentheses portion till later. And the parentheses portion is being multiplied by h and by 1/2. So we're going to need to undo each one of those things. So I'm going to rewrite this equation so that we can do some work on it. Okay, so A equals 1/2 h times b1 plus b2. Okay, so what I see here is we don't have any math to do because we're working with all symbols. There are no like terms because everything's a variable and we can't combine anything. So we have to go right to that undo the math section. And so again, we have to work outside of the parentheses. Outside of the parentheses we have 1/2 times h times the parentheses. So there's no addition or subtraction. We need to go right to undoing the multiplication and division. So let's start with the 1/2. The opposite of multiplying by 1/2 is multiplying by, change colors here so it stands out. We're going to multiply by 2 over 1. And if we multiply by 2 over 1 on the right, then we also have to multiply by 2 over 1 on the left. 2 over 1 is just 2, so we have 2a on the left-hand side. This all canceled out, and that leaves us with h times our parentheses b1 plus b2. Okay, so now what we have is we have 2a equaling h divided by h times b1 plus b2, and the b1 plus b2 is there in the parentheses. And again, we still have some stuff outside of the parentheses to work with, so we're not allowed to go into the parentheses yet. And so right here with our h times, we need to undo that. So to undo h times b1 plus b2, we're going to divide by h. Okay, so technically we're dividing this whole thing by h. The important part is that h divided by h is just 1. Anything over itself is 1. And if we divide by h on the right-hand side of the equal sign, then we have to divide by h on the left. These are going to become a 1 and drop out. We're now left with 2a over h equal to, now on the right-hand side, since the only thing that's over there is parentheses, and everything inside, we can ignore the parentheses. The parentheses can go away, and we can write this as b1 plus b2. So now virtually I've gotten to the point where I'm inside the parentheses, and I see that the operation that I need to undo is addition. And so what I'm going to do is I'm going to subtract b1, because this is a positive value right here. This is plus b1, positive b1 plus b2. So I'm going to subtract b1 on both sides. Okay, so b1 on this side, and I'm going to subtract b1 over here, minus b1. Let me rewrite that. 2a over h minus b1 is equal to b2 is all by itself. And so we get a value for b2, or an equation for b2, that is 2 times the area divided by the height minus the base 1 will give us a value of b2. So if I happen to know the area, the height, and base 1, I can solve for the length of base 2 in that trapezoid. And so you can see that we can continue to follow the same rules as we work through these problems that have only variables in them. And again, we're going to go to the next screen, guided practice problem for you to try. Deals with the surface area of a cylinder. There's the equation. And in this case, you're asked to solve for h. You want to make this thing say h equals. Remember that what you're doing is you're using Sally, Aunt, Dear, My, Excuse, Please. Again, we're going to undo the addition, subtraction, multiplication, division, any exponents that are involved, and then any parentheses. So pause this. Good luck with this one. And again, the answer will show up at the end of this video. Okay, when you're finished with that guided practice problem, we can move on to example 7. And example 7 is trying to prepare you for standardized tests, things like the SATs or any other standardized math tests that you may need to take. They ask you to use properties of equality to solve this equation. And I want to be careful when I say that, because you're not actually solving the equation. We're not actually going to find a value for x. We have to pay attention carefully to what this says. It says if 6x minus 12 is equal to 18, then what is the value of 6x plus 5? So we actually want to know, what does 6x plus 5 equal? That's the question. So we can look at this and notice that it does say use properties of equality. Now, there are many ways to solve this problem. We're going to go over the one that specifically uses properties of equality. So I want to think about this in terms of, can I make this equation that I have, the one that I know a final value for, 18, can I make it look like this one? Can I make 6x minus 12 equals 18 look like 6x plus 5? And if we were to go back a couple screens to those properties of equality, we kind of start to see some equations that can make that happen. So 6x minus 12. Can I make that look like 6x plus 5? Well, what if I were to write it as 6x minus 12 plus 5? So now, on the left-hand side of my equation, equals 18, I have the 6x that I need, and I have the plus 5 that I need. Now, to this equation, I just added plus 5 on the left. And what do we know? That if we add something on the left side of an equation, we also have to do it on the right. So if I added a plus 5 to the left side of my equation, I also must add a plus 5 on the right. And so I haven't actually changed my equation insofar as the two sides of the equation are still the same. They were the same because it said equal. They remain the same because I did the same thing to them. I added 5 on both sides. And so I'm going to rewrite this just in a different order. 6x plus 5 is what I want, minus 12. I'm allowed to do that. I can change the order. Equals 18 plus 5 is 23. So now 23 is on the right-hand side. All I did was do the math there. I was allowed to add that. And I want to leave the 6x plus 5 just like this. And so in this case, I want to think about that like my variable, like it's one big x, and I want to leave it alone. And to do that, I need to get rid of my minus 12. Well, how do I get rid of minus 12? How do I undo subtracting 12? Well, if I'm subtracting 12 on the left and I want to undo that, I'm going to do the inverse operation. I'm going to add 12. And if I add 12 on the left, then I also need to add 12 on the right. This minus 12 plus 12 becomes 0. I'm left with 6x plus 5 on the left-hand side of my equation. And I'm going to end up having that equal to 23 plus 12, which is 35. And the question asked me, what is 6x plus 5 equal to? Well, 6x plus 5 is equal to 35. So 35 is choice C. So on a standardized test, I'm going to choose choice C. Is that the only way to solve this question? No. Is that a way to solve this question using properties of equality? Yes, absolutely. Another way to do this is to solve the original equation, this equation right here, for x, and then plug x in to this equation. Many ways to do this problem. The way that we want you to pick up on how to do it right now and use the properties of equality is the way that I just demonstrated here. And on the next screen, we have a guided practice problem that is very similar. Pause the video now, give this one a try. Okay, now that you've tried that one, I want to remind you that you have 24/7 book access at connected.mcgraw-hill.com. Today we talked about section 1-3, examples 4 through 7, which are located on pages 19 through 21. We're going to move over to the next screen for the guided practice answers, and the screen after that will have your homework assignment on it. Here are the guided practice answers. Pause the video now, take a look at them, compare them to your answers, come prepared with questions to class tomorrow. And here on this final screen is your homework assignment. Examples 4 through 7, these are the question types that we tried here. We solved single-step equations. We solved multi-step equations. We did some work with formulas and using more variables. And we had a multiple-choice practice problem for a standardized test. Please try these. Come to class prepared to check your answers first thing.